Hi, so I thought I would talk about a brief introduction to programming languages. Don't worry if you don't get all of this. Feel free to ask questions and I'll redo this video later on if you feel it's of importance. But this will help, if you do understand what I'm talking about here, this will help reduce costs in your business ventures as well as make good decisions later on in how you implement products. You'll often hear about different programming languages. Thousands have been widely used, grown to be hugely popular, and then come crashing down overnight or slowly been phased out of use. Some have endured. The cycle repeats in the programming industry. So what's the difference? Why choose one programming language over another? Oftentimes, programming languages are good for different things. They have programming languages that are good for building out graphics or animations or better for dealing with data. I've seen it broken up in numerous ways, but to start off, I like to break it up into the following categories for understanding purposes. I like to say that there are low-level languages, mid-level languages, and high-level languages. These are the main categories of languages, and all languages fall into one of those. Low-level languages are used for interacting directly with hardware. These include assembly or machine code. So if you ever watched one of those old movies like Hackers or other old movies from the 80s that dealt with computers, you'll see them typing in ones and zeros or they'll flood the screens. That's machine code. And that's basically, the ones are basically voltage, and the zeros are ground, if that makes sense to you. Or they're basically electrical pulses to an electrical component. But this is getting too complicated already. So the thing about low-level languages is they're highly dependent on the setup of your computer. So if you have a monitor plugged in to a particular plug in the computer, and that is attached to the actual, in order to send a message to it in assembly, you have to specify that. It's, if you were to have another computer that had the monitor attached to a different part of a circuit board, that program suddenly wouldn't work. So low-level languages are dependent on the configuration of your hardware, and there's no reason why you would use them unless you needed to save power or create something that ran extremely fast. And in those cases, you could usually just convert it into hardware or actually create a circuit for it. Because there is so much more involved with creating a complex program with assembly or machine language, I don't recommend using it in most cases if those aren't an issue. Some examples of things that could use where it might be necessary to go and use assembly is the Mars rover, heart pacemakers, or anything that would run on battery that needs to run for a long time. Or for speed, algorithmic calculations, you might want to do it there. But at the same time, you probably want to implement it in hardware, because although low-level languages are very quick, hardware will always be more efficient. A shortcoming of low-level language, outside of the amount of code bulk you have to create, and by bulk I mean the amount of lines of code, you're going to have to write a lot more code, is that they will only run with one hardware configuration, as I said before, and it's not portable from one configuration to another. So that's my personal opinion, but now let's get to middle-level languages. Middle-level languages took a lot of the complexity of low-level languages out of the picture. So now with middle-level languages, like C, it's more human readable, it's easier to understand, number one. It's not as dependent on the hardware configuration. You don't have to work with the individual hardware components when writing out the code, a lot of that's taken care of for you. They were made popular initially because they reduced the amount of code you have to write. Furthermore, it compiles into machine language and assembly language, and by compile I mean it's converted by another program into that language without you having to do it. So you can write less lines of code, and the conversion will happen for you, so you can actually create things faster with it. Furthermore, when writing with low-level languages, you have to know more about and compensate for more in order to use that language. With middle-level languages, you have to know less, and those complexities are usually taken care of for you. An example of a middle-level language is C, but they still had shortcomings in that they had insecure functions because security wasn't much of a thing when back in the 80s or even early 90s. So they have a lot of security loopholes inherently exposed if you use them improperly, but we won't get into that because in most cases, and in our case, we're going to be working with high-level languages, and I'll explain why afterwards. With middle-level languages, you still have to worry about the operating system. So while they're not specific to the hardware configuration of the computer you're working with middle-level languages, they will usually only work with one operating system like Windows or Mac OS or Android, etc. Right? So the strong point and the major takeaway for middle-level languages and the major leap from low-level languages is the existence and creation of the compiler. It allowed your code to be converted into machine language, and at the end of the day, it allows you to write code exponentially faster. So there's clearly an improvement there, but there's room for more improvement. This is where higher-level languages came into play and were invented. Higher-level languages, which are the majority or the main language you should be using in your everyday ventures and everything that you build out, are like C# and Java. You've probably heard those, even though you might not know what they are. These languages take care of everything middle-level languages did and more. Furthermore, they run on top of something called another program called a virtual machine, which allows you to write a single piece of code that'll work on any operating system. So you do it once, it works everywhere, which was, in my opinion, one of the major leaps. Furthermore, they take care of issues that you would have to handle in the middle-level languages and low-level languages, like the amount of space they took up or how you processed the information. In middle-level languages and low-level languages had something called a buffer overflow, which we will not discuss, but in most cases in higher-level languages that issue doesn't exist because they coded it so that you couldn't recreate it. So Java, you cannot have a buffer overflow issue occur with it. While in C#, if you use it incorrectly, you still can, but in most cases, that's just pushing it. You must do something very wrong in order to be able to accomplish that with it. So by the use of the higher-level languages, it's harder to run into memory management issues, security issues, as well as code it in a very bad way and make highly complicated code that no one can understand. It's still possible, but it's much harder. Furthermore, I think you should use this in the higher-level languages in most cases, if you're not limited by hardware speed, memory, or power usage. And in most cases, you're not, because memory is cheap and hardware is cheap now. You can buy a computer for like $200 if you really want a cheap one, or less. So that is a brief overview of programming languages.